This video tutorial is on percentage. The definition of percentage is percent is derived from the Latin word percentum, meaning per hundred. And the symbol used to represent percentage is this symbol. Now, the definition says percent is derived from the Latin word percentum, meaning per hundred. Per hundred, right? So, let's understand this definition by a few examples. If our fraction is 1 over 100 and 2 over 100, then if by the definition it says percentage is per 100, so by going by this definition, this is 1 per 100, that is 1 out of 100. Therefore, this fraction is actually represents 1%. And this fraction 2 over 100, that is 2 per 100, represents the fraction 2%. Clear? Suppose we have a fraction 3 over 5. Okay. Can we tell what percentage this is? That's really very simple. You have to remember the concept of equivalent fractions. And I assume that you remember the concept of equivalent fractions. So if I apply the concept of equivalent fractions and if I multiply this 3 over 5 by number, that is both the numerator and the denominator, by 20, then this will give you 60 over 100, right? So 3 over 5 and 60 over 100, these are like, this fraction is equivalent fraction of this one. This represents 60%. Why? Because it is 60 out of 100. Now, if this fraction was not 3 over 5, but if this fraction had been 3 over 7, let's say 3 over 7, then can we tell the percentage? Same thing. You have to remember the concept of equivalent fractions, and in this case, now here, if we multiply 20 with 5, then straight we get 100. But that is not the case with 7, because 7 is not a factor of 100, right? So in that case, what will we do? That's again very simple. 3 over 7 and multiply this with 100 over 100. Because 100 over 100 is nothing else but it's actually 1 only, right? If you solve this, you'll get 1. So it means that what? 3 over 7 is multiplied with 1 will give you back this fraction only, right? So why we have done this? Because again, we are using the concept of equivalent fractions. We need 100 in denominator in order to tell the percentage. Therefore, we have 100 by 100. And if we write it in this way, 3 over 100 divided by 7 times 1 over 100, right? We can do this? Yes. Now, if you solve it, this is 300 over 7 plus multiplied by 1 over 100, right? Now, this will give you 7 for 28, you get 2, then 7 to 14, you get 6, 42.8 something you are getting from this one, right? If you divide this, 7 times 4 is 28, then 2 carry over, 2 0, 7 to 14 and 6, yes, 42.8 something times 1 over 100. Now clearly this can be written as 42.8 divided by 100. So what percentage is this? This is 42.8%. So by using these examples of fraction, I actually tried to explain you this definition, that is per 100, right? When you are dealing with fraction, always try to get 100 in the denominator, because when you have to tell the fraction percentage, you should have 100 as a denominator. Okay, let's take a few more examples. Suppose we have this rectangular block, right? And if we cut this rectangular block into 100 equal pieces, we go on cutting this. Okay, so total, this is the 100th one. Suppose this is the 100th one. Again, if I talk about this one, what fraction will this represent? This is 1 over 100. So what percentage is this? What percentage this portion is out of this whole block? This is 1%. Similarly, if we take this one and this one, both this one, right, these two, so in that case, these two are actually what? These are 2 over 100. That's considered a fraction. So what percentage will this is this? This is 2%. Okay, so again we can see that what do we mean by percentage? We cut this block into 100 equal portions, and then each portion is actually representing some fraction. If I take only this one, this is 1%. If I take these two, that is 2%. If I take this one, and this one, that will be 3 over 100, that fraction, and the percentage will be 3% in that case. Right? Okay. Suppose in a class, in a whole class, and the strength of the class is 100, there are 60 girls and 40 boys. Okay, so 60 girls and 40 boys. What fraction are these girls in the whole class? So in the whole class you have 60 girls and the total strength of the class is 100. So this again 60 over 100, that is 60%. The fraction of girls in the class is 60 over 100, and this fraction tells us represents a percentage, that is 60%. The fraction of boys in this class whose strength is 100 is 40 over 100. Okay, and this represents a percentage, that is 40%. Okay, so this is a very basic thing about percentage, that is, always remember this thing, it's always per 100. You have to consider things per 100. Let's take a few more examples. Suppose this is a boy and this is a girl. After an exam, boy gets 330 marks out of 400, and the girl gets 350 marks out of 400. Okay, now in this case the girl says that since I have got 350 out of 400 and you have only got 330 out of 400, that is why I'm the winner. Okay, I'm the winner and my marks are greater than yours. Okay, but suppose if this boy got 330 out of 350, suppose, and this girl got 350 out of 370. Suppose. Now can you tell whose percentage is actually greater? Who has got more marks? That's not so easy by just looking at this number in the numerator, because now this is 330 out of 350 and this is 350 out of 370. So in that case, the concept of percentage comes. It plays a very important role. And let's understand this. So I'll explain you using two different ways of calculating percentage and then telling you who is actually the winner in this case. First, by using fraction method, what we have seen just in our earlier slide. So using fraction, what fraction is this? This is clearly 350 divided by 370, right? If I further solve it, this is 35 divided by 37, right? And this is 330 divided by 350. If I further solve it, this is 333 divided by 35. Now, how can we calculate the percentage in these cases? Very simple. Multiply this with 100 divided by 100, the concept of equivalent fractions, and in this case by 100 divided by 100. Okay. Now, if I solve this one, 35 times 100 divided by 37 and 1 over 100, and this one as 33 times 100 and divided by 35 1 over 100. So in this case, this is, if I solve this one, I'll get 94.59, and in this case, if I solve this, I'll get 94.28. I can write it as 94.28 over 100, and this is 94.59 over 100. So now this one has the denominator 100. Now we can quickly tell what percentage is this. This is 94.59%, and this one is 94.28%, right? Clearly 94.59 is greater than 94.28, right? Therefore, yes, this girl has got greater marks in comparison to this one, right? So this one was using the concept of fraction. But now I'm going to tell you the concept of calculate percentage using unitary method. We have seen here using fraction, but now let's talk about unitary method. So how will you calculate a fraction percentage? For this girl, this girl has got 3 out of 370, she has got 350 marks. Okay, remember the unitary method? We first calculate for one and then for the number that we want for. So out of 370 she got 350 marks. Then we'll calculate for 1 out of 1. That mark will be 350 divided by 370. Therefore how many marks she will get out of 100, right? Again, you remember the unitary method. Out of 370 she has got 350 marks. Now we have to calculate for 100, so first we'll calculate for 1, then for 100. So out of 100 she will get 350 divided by 370 times 100, right? This is out of 100. Out of 370, these many marks. Out of 100, these many marks. So again, solve it. This is 350 divided by 370 times 100, right? And you will get this, again the same thing, 94.59 if you solve this one, right? Now since this 94.59 is actually out of 100 only, 350 marks was out of 370. Now out of 100 she will get, if we calculate for 100, the marks is 94.59. that is 94.59%. How did this percent come? This came because we have calculated out of 100 now. Same thing here. This boy out of 350 has got 330 marks. So out of 1 we are applying the unitary method, that is 330 divided by 350 marks. Therefore out of 100, how many marks he gets out of 100? If we calculate using unitary method, that will be 330 divided by 350 times 100 marks. Okay, and this will be 94.28 marks. What percentage is this now? Since this 94.28 is actually out of 100, therefore the percentage will be 94.28%. So here we have used fraction, and in this one we have used unitary method. Okay, moving on. This is the last example. So we have 5 red balls, 2 blue balls, 3 green balls. So total we have how many balls? We have 10 balls. We have 10 balls. Now in this case we have 10 balls, and we have to calculate again the percentage of red balls, the percentage of the blue balls, the percentage of these green balls out of the total 10 balls. So how will you calculate? That's very simple. Again, first using fraction. So if I use fraction, and if I calculate, first I'm talking about percentage for percentage for red balls. Okay, so in this case, what is a fraction? That is 5/10, right? 5 balls out of 10. So this is 5/10. And if I have to calculate percentage, I'll use the concept of equivalent fractions. And if I multiply the numerator and denominator by 10, because clearly if I multiply 10 to this 10, I'll get 100 in the denominator. So this will be 50 out of 100. This is 50%. What percentage it represents? It represents 50%. Now let's talk about percentage for this blue ball. In this case, what is a fraction? 2/10. Again, if I multiply both the numerator and denominator by 10, I'll get 20 over 100, because 10 is a fraction of 100, so 10 times 10 is 100. This represents 20%. Okay. Next one is percentage for green balls. In this case, the fraction is 3 over 10. So this is the equivalent fraction for this one will be 30 over 100. If we multiply the numerator and the denominator with 10, so 30 over 100. And what fraction does it represent? It represents 30%. So the percentage of red balls is 50%. The percentage of blue balls is 20%, and the percentage of green balls is 30%. Now let's solve it using unitary method. Okay, so first for the red balls. In the case of red balls, out of 10 red balls, out of 10 total 10 balls, you have 3 red balls. Therefore, we'll first calculate for 1. That will be 3 over 10 balls. Then we'll calculate for 100. Because we want how many red balls will be there if we take the total number of balls is actually 100. So out of 10 it was 3, out of 1 it will be 3 by 10. So out of 100 it will be 3 over 10 times 100, right? Now, if you solve this, you'll get 30. Sorry, this is 5 balls. This is 5 balls. 5, you get 50 balls. So if the total number of balls is 100, in that case, the red balls will be 50 balls. Now, what percentage will it represent? It will represent 50%, because we have calculated for 100 balls. In the case of blue balls, the fraction will, in the case of blue balls, out of 10 balls, you have 2 blue balls. Therefore, first calculate for 1 out of 1, that will be 2 over 10. Then for 100. So if the total number of balls is 100, the number of blue balls will be 2 over 10 times 100. And if you solve this, you will get 20 balls. So there will be 20 balls, 20 blue balls. And what percentage does it represent? It represents 20%. Why? 20 out of 100. For green, out of 10 balls, you have 3 green balls. So first calculate for 1, that will be 3 over 10. Then calculate for 100. So if the total number of balls is 100, then you will have 3 over 10 times 100 balls, green balls. This will give you 30 green balls. And this is actually 30%, right? In both the cases, here 30, 20 and 50, here also 30, 20 and 50, you are getting the same result. So using fraction and then using unitary method. Now, one very last important thing. Here we have considered this as a whole unit, right? A unit of 10 balls. In all these cases, whether you solve using unitary method or you solve the fraction method, you are getting the same fraction. And one very interesting thing, what's that interesting thing? That is, parts always add to give a whole. And what does that mean? That means you can see here that's 50%, it's 20%, and this is 30%. Just add them up. This is 50%, this is 20%, and this is 30%. If you add them, you'll get 100%. Now what does 100% means? It means what? 100 over 100, right? Percentage means what? 1 over 100. So 100 over 100, this gives what? 1. That means it's a complete whole unit. It's talking about complete whole unit. 100% means what? A complete whole unit. So if we add up these individual percentages, in this case we have red, then blue, then green. If we add up these individual percentages for this complete unit, you'll get the whole. And why is it important? Suppose someone tells you that, you know what, you have 50% of red balls and you have 30% of green balls. Okay, so someone tells you that, you know what, we have actually 3 different balls, red, blue and green. We know the percentage of red balls and we know the percentage of green balls. Can you tell us the percentage of the blue balls? That's really very simple. Why? Suppose the percentage, in this case percentage of red balls is 50, percentage of green is 30. We don't know about the blue one. So what you will do is, you'll assume that, okay, let's assume that the percentage of the blue one is what? X%. And if I add these individual percentages, it should come 100%, right? 100% means what? A complete whole. So from here, you will calculate X% as 100% minus 80%. And this will give you, why 80%? 50% plus 30% is 80%. So if you do subtract it, it will be 100% minus 80%, and this will give you 20%. Can you see here? You have 20%. So when you are taking a complete whole unit, a whole unit will represent 100%, and if you add up the individual percentages, then you'll get the complete 100%. And even if you have to calculate a missing percentage, and if you have enough information, then you can calculate that missing percentage by using this one. That is, the percentage of the complete whole unit will be 100%. So this was about percentage.